All right, so here's this last one. Now, you can see we're on a slope again, okay? But the water is underneath the gate instead of on top of it, okay? But we're still going to use the same trick. Let me make this bigger, where we deal with a lateral force acting on it here. So we're going to have an Fx, okay? And then we're going to have an Fy2. An Fy as well, but it's going to have two different parts. One part of the Fy is going to be the pressure pushing on this area right down here, and that's going to be an upward force there. So let me call that Fb. That's going to be pushing up from below. So you can sort of imagine if that thing wasn't at an angle, but it was like a flat somehow. So you had water stacked up on one side and it came over and you had like a window. You know that if you got a crack in the window, water would come spraying up there. So there's an upward force there because of the pressure. Okay. All right. Now, but what we have here is we also have the weight of this triangle. Okay. Just like that. So when we get ready to figure out the y component acting on the gate, what we're going to do is we're going to say FB minus the weight. Okay, so that's how that's going to work out. And then, like I said, we will just end up combining those things using the Pythagorean theorem. Okay, so let's go ahead and get Fx on here. Okay, so, all right, and I'm just going to write down what we have, rho g y, and then we know it's z bottom squared minus z top squared. Okay, now I prefer not to try and memorize these things. I like to just get them from scratch, but we've used this several times now, so it's starting to get burned into my brain. I can just remember what it is. Okay, now in this particular question they give us a gamma. So remember, the gamma is this thing right here. Okay, and so that means if we rewrite this a little bit, we have 1/2 gamma y zb squared minus zt squared. Okay. All right, now zb at the bottom here, zb is going to be 10, and zt is going to be 6. All right, so this is the top and there's the bottom right there, just like that. Okay, so if we put in all of our numbers to get that x component, I've got 1/2, 62.4. Okay, and again, for the sake of time and messiness, I'm going to not put the units on here. It's 2 feet. That's my value for y. Got that right there. And then I put in 10 squared minus 6 squared. Okay, and the number that I'm going to get for that is 3994, and we're in English units, so that's pounds. Okay. Now, let's get the force from below. Okay, so the force from below is going to be equal to that pressure below times the area. All right, so that's going to be rho g, whatever that depth is. There's my pressure. And then my area, which is going to be the 3 times 2. All right, just like that. Now ZB, our depth is still 10. So if I put in all of my numbers there, actually I didn't work it out in my notes. Sorry about that. Okay, let's get the weight while we're at it here. So that's going to be rho GV, which is gamma V, which is going to be gamma times 1/2 base times height times our width term there. Okay, and I didn't work that out either. I just have it as numbers written on my page. What I actually calculated was the number that you get for Fy, which is going to be FB minus the weight. Okay, and that number turns out to be 2995. So I just did it in one step in my work. Okay. So now our actual force, we're going to have Fx squared plus Fy squared, like so. Okay. So 3994 squared plus 2995 squared gets us to 4992 pounds. Okay. And there's our answer just like that. Okay. So all of these are going to be some kind of combination of this. We're going to have to integrate something on the side. All right. Or maybe you can just use the geometry to get the weight, that sort of thing. So you got 3 good tools to work with here. All right. So integration for the vertical stuff. For top and bottom, you can use pressure and area, or you can use the weight, or maybe like this one, you might have to do both. Okay. There you go. Not too bad. Pretty straightforward.